Langkah laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Buah durian, buah jambu, lebih enak lagi buah duku. Selamat datang ke Pusat Tuisyen PERCUMA AYU, rajin belajar, bertambah ilmu. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera dan selamat petang diucapkan kepada semua pelajar yang dikasihi, guru-guru dan ibu bapa di mana jua anda berada. Kami doakan anda sentiasa berada dalam keadaan yang sihat sejahtera. Petang ini sekali lagi kita dipertemukan dalam siri yang seterusnya untuk kelas fizik tingkatan 5 dengan tajuk kita pada hari ini ialah 6.2 radioaktif decay. Okay, sebelum itu cikgu ingin berpesan kepada semua yang mengikuti kelas pada petang ini, anda bolehlah menggunakan gambar profil yang bersesuaian dan jika ada soalan yang ingin ditanyakan kepada Mr. P, anda bolehlah kongsikan pertanyaan anda pada ruangan chat di bawah. Okey, sebelum itu cikgu perkenalkan dahulu barisan petugas yang ada di konti pada petang ini. Yang pertama presenter kita sendiri iaitu Cikgu P. Kok Hua ataupun lebih dikenali sebagai Mr. P dari Kolej Tingkatan 6 Tun Fatimah Melaka. Dan kita ada Cikgu Kok Simai di sana selaku control host kita pada petang ini dari SMK St. David Melaka juga. Jadi bagaimana cuaca di Melaka? Cikgu Kok, Mr. P.
Okey lah.
Macam
Okey ya.
boleh tahan.
Boleh tahan Okey, dan saya sendiri Cikgu Hasnita binti Andy Mario dari SMK Bagan Jaya Pulau Pinang selaku moderator anda pada petang ini. Jadi sebelum cikgu mulakan kelas, marilah sama-sama kita mulakan majlis dengan ummul kita Al-Fatihah bagi yang beragama Islam, dan bagi yang bukan beragama Islam anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya rabbal alamin. Jadi cikgu harap kalau semua sudah bersedia, anda boleh type tak pada ruangan chat. Sudah bersedia ready teacher, ataupun boleh tuliskan nama anda, boleh perkenalkan diri dari sekolah mana anda belajar. Jadi tanpa melengahkan masa lagi, tapi sebelum itu, sebelum cikgu serahkan kelas kepada Mr. P, izinkan dulu cikgu berkongsi kod kelas kita pada petang ini. Dengarkan kodnya baik-baik, iaitu A3. A3. Kod ini anda simpan dan anda boleh gunakan untuk mengisi borang klaim rekod kredit di akhir siri ini nanti, dan kami juga akan kongsikan link sijil kelas ini bersama-sama dengan link rekod kredit. Jadi anda boleh isikan menggunakan email yang tertentu, iaitu email EDD, email MOE Delima, email MyJawi dan juga email e-guru. Okey, baiklah pelajar-pelajar semua, semua pun sudah tidak sabar, jadi tanpa melengahkan masa lagi, cikgu persilakan presenter kita Mr. P untuk memulakan kelas pada petang ini. Silakan Mr. P.
Okey, terima kasih kepada Cikgu Hasnita. Saya Mr. P kini mengajar di Kolej Tingkatan 6 Tun Fatimah Melaka selaku presenter pada hari ini. Di room chat saya nampak ada Chayao, okey, dan lain-lain hasilnya. Okey, so selamat petang. Okey, welcome join kepada kelas saya hari ini. Okey, so sekarang saya nak buat promosi. Okey, so ini adalah kelas tuition PERCUMA AYU. So untuk kelas tingkatan 4 diadakan pada setiap hari Jumaat 9.30 malam, dan kini kita sudah sampai subtopik 5.2 perlembapan dan resonance, dan disampaikan oleh Cikgu Rosmawati. So siapa yang belum lagi attend kelas tersebut, bolehlah visit channel Cikgu Ros. So untuk kelas tingkatan 5 diadakan seperti hari ini pada setiap hari Ahad pukul 2 petang. Dan ini adalah panitia fizik SPM AYU. Dan hari ini bersama saya di konti ada Cikgu Kok dan juga Cikgu Hasita. Okay, terima kasih Cikgu Kok dan Cikgu Hasita. Okay, bersama saya pada petang ini. Okay, so we are continue to our chapter 6, which is the nuclear physics. And today's lesson will be going to subtopic 6.2. There is nuclear energy. And this will be the last subtopic for our chapter 6. Okay, and for today's learning standard, we have total about 5 learning standard. So this is the learning standard 1 for subtopic 6.2 is to communicate about the nuclear reaction, which are nuclear fission and nuclear fusion. So students, you must able to know what's the difference between the nuclear fission and nuclear fusion. And this is actually the extended knowledge, what you actually have the basic at PT3 level already. Okay, so how nuclear energy is produced? Nuclear energy is the result of nucleus reaction. There are two main nuclear reactions, which are nuclear fission and also the nuclear fusion. So for the nuclear fission, the definition will be splitting the heavier nucleus into two lighter nuclei and releases a large amount of energy. So you can look at the figure here. So the heavy nucleus here is uranium-235. Okay, so you can observe the neutron number, which is 235, and it will be splitting to become two lighter nuclei. Okay, so you can look at the neutron number for Kr and also the barium. So both is become lighter than the uranium-235. So this is the definition where the heavier nucleus will be splitting, okay, to become two lighter nuclei and come together with the energy. Okay, and another one will be the nuclear fusion. So the nuclear fusion is the combination of two lighter nuclei to form a heavier nucleus with the release of large amount of energy. So you can look at the figure here. So you can see here we have the two isotopes of hydrogen. So there is deuterium and also the tritium. Okay, so both have the same proton number, so they will be hydrogen. Okay, however, they have the different neutron number, which is 2 and 3 respectively. So both of these hydrogen is actually the isotope. Okay, and the neutron number, which is stated as 2 and 3, is lighter than the product, which is become 4 after the nuclear fusion here. So that means here the nuclear fusion will be combined two lighter nuclei and become more heavier nucleus, which is helium here. And both of the nuclear fission and fusion will release a large amount of energy. Okay, so here, as I mentioned, the product for the nuclear fusion will be have heavier nuclei compared to the previous lah. Okay. Okay, so now we go to the detailed discussion for the nuclear fission. Okay, so you can look at the figure here and also the GIF. Okay, so a slow neutron here is captured by nucleus uranium. Here will be 235 here to become uranium-236. So when the neutron is bombarded to the uranium, so the neutron number will temporarily become 236, and it is a very unstable element and will be quickly to splitting into two smaller nuclei here. Okay, so the nuclei here mentioned is Kr and barium. So actually they can have others example lah. As long as the product for the nuclear fission, the nuclei will have the smaller numbers of neutron compared to the uranium, okay, which is the reactants lah, okay, before the nuclear fission occur. Okay, and go together with the 2 or 3 neutron. So you can look at figure here. They will be releasing 2 or 3. Here the figure showing the 3 neutrons will be released after the nuclear fission. Okay, and come together with a large amount of energy. Okay, which is normally be using to generate the electricity. Okay, so you can see here the example of the reaction can be write as the equation here. Okay, so the neutron will have 1 neutron, 0 proton. Okay, and here will be the neutron number and proton number for uranium, Kr, barium, and product of neutron here. So 3 here mentioned that the reaction in figure here produce 3 neutrons, okay, together with the energy. So the energy will be using to generate the electricity, okay, in nuclear reactor. And this will be discussed at our learning standard 4 later on. Okay, and then the next will be the nuclear fusion. So you can look at the figure also together with the GIF. Okay, so the fusion of a fast-moving deuterium. Okay, deuterium will be here lah. Okay, collide with the tritium will be here. Tritium and fuse together to form a heavier helium here, and together with releasing the large amount of energy here. Okay. So the temperature of gas must be high, giving a high average kinetic energy. Due to the requirement of the high temperature, nuclear fusion is known as thermonuclear reaction. Okay, so there is a difference between nuclear fission and fusion here. So the nuclear fusion require a high energy so that the isotope of hydrogen here will be gain high kinetic energy, and both of them will be collide and fuse to become heavier nucleus, which is the helium here. Okay, while for the nuclear fission, the requirement is needing a slow moving of neutron, but no need to require a high energy to initiate the process. So again, so you get the figure here, we can showing the occurrence of the nuclear fusion in this diagram into the equation here. Okay, so H21 will be the deuterium, collide together with the tritium 31 here, and become helium 42 and neutron together with the energy. And this is actually how the sun get the heat and light and through the process of fusion here. Okay, so that's why the surface of the sun consists of a lot of the hydrogen and also the helium. Okay, so the hydrogen in the sun will be using for the fusion to release the heat and light to Earth lah, so that our plant can conducting the photosynthesis. Okay, so and then there is terms of chain reaction here. So what is the chain reaction? So a chain reaction is a self-sustaining reaction in which the product of the reaction can initiate another similar reaction. So we know as a continuous or nuclear fission process. So here already mentioned that nuclear fission. So that means the chain reaction here referring to nuclear fission, where the process can be continued to process, okay, until the reach of the critical mass. So what is the critical mass? Later on we'll discuss together. Okay, so in nuclear chain reaction, the succession of the fission depends on the production of nuclei and the capture of neutron. Okay, so here you can look at the GIF or solar. Okay, so the neutron will be released and then trigger the uranium 235. Okay, so you can look at the sentence number 3. A neutron bombard a uranium nucleus, then 2 or 3 neutrons are produced. So you can look at the GIF or you can look at here. Okay, so 1 neutron bombard to the uranium-235, then will be released the 3 neutron here. So the 3 neutron here will be continue to bombard another uranium-235. Okay, so this neutron produced will bombard another uranium nucleus. Okay, so you can see the process will be continue until, as I mentioned, reaching the critical mass. Okay. Okay, so for each reaction, more neutrons are produced, causing a chain reaction until the mass of the uranium nucleus reaches the critical mass. Okay, so what is the critical mass here? So the critical mass is the minimum mass of the nuclear fission that will sustain a nuclear chain reaction. So that means that when the mass below to minimum mass, which is known as a critical mass, the chain of the reaction will be stopped. Okay. Okay, so you can look at the sentence number 7. As uranium atom continue to split, a significant amount of energy is released during each reaction. So here we have equation which is E equal to mc squared. So we will also have further discussion regarding this formula. Okay, so that means the energy will be released as mentioned in both nuclear fission and fusion. But here we definitely discuss about the fission. So the energy release will be able to calculate by this formula, each equal to mc squared. M will be the mass defect, C will be the speed of the light. Okay, so the heat release is used to generate electrical energy. So this will be our learning center 4. So how the heat released from the nuclear fission here able to produce electrical energy. Okay, so here is the GIF, okay, how the production of the electrical energy by using the nuclear energy. So later we also have a time, okay, for detailed discussion. Okay, so a control chain reaction is used in nuclear power station. So that means that the chain reaction is controlled under the nuclear power station. Okay, so an uncontrolled chain reaction is used in nuclear bomb. So that means that if I say the chain reaction is not able to control, so will be very dangerous. Okay. Okay, so the next come to the comparison between the nuclear fission and nuclear fusion here. Okay, so here you can see the figure for the nuclear fission will be the splitting of heavier nucleus, okay, to 2 daughter nuclei, which is lighter and together with the 3 neutron and also the energy. Okay, and then the nuclear fusion here is also same as the previous discussion. So both the isotope of hydrogen, which is lighter, will be combined and become a bigger nucleus here, okay, which is a helium. Okay, so here we discuss the 4 similarity between the nuclear fission and nuclear fusion here. So the first, both will be release large amount of energy, and the energy can be calculated by using E equal to mc squared formula. Okay, and then the second similarity here will be both will be occur to nucleus, new element form. So for example, you can look at the nuclear fission, the product will be Kr and also beryllium. Okay, and then for the fusion here, the product will be helium. And the last will be produce mass defects. So the mass defect is known as a loss in the mass, which is converting the kinetic energy to thermal energy here. So that's why just now I mentioned that the nuclear energy able to generate electricity because it can produce heat energy. Okay, so both of the processes, okay, which is a nuclear fission and fusion, will be have the loss of the mass and converting to energy. Okay, and the relationship will be using the formula lah, E equal to mc squared. Okay, and then the differences. Firstly, the fission does not occur naturally. Okay, so we need to have a slow moving neutron to initiate the process. Okay, while for the nuclear fusion occur in sun naturally. Okay, so this is the first difference between fusion and fission. Okay, then second, the nuclear fission is a process of splitting heavier nucleus into lighter nuclei. Okay, as mentioned just now, and also the figure here already. While for the nuclear fusion, the process is fusing two lighter nuclei to form a heavier nucleus. Okay, so the nucleus will be helium lah. The third difference will be the nuclear fission initiated by slow neutron does not need high temperature, while for the nuclear fusion is initiated by very high temperature, okay, which is required by the isotope of hydrogen to gain more kinetic energy and fuses together to form heavier nucleus, which is the helium here. Okay, so the fourth difference here, large numbers of nuclear waste are produced for the fission. Compared to nuclear fusion, there will be no nuclear waste product in this process. Okay, so the nuclear waste will be referring to the product, okay, for the fission. For example, here will be the barium and also the krypton here. Okay. Okay, so we have already finished our learning standard 1. Okay, so we go to our learning standard 2. Okay, so which is the describe relationship between energy released during nuclear reaction and the mass effect. So this is the E equal to mc squared, which is a very important theory, okay, invention by the Albert Einstein here. Okay, so the energy in a nuclear reaction. So both nuclear fission and fusion release a large amount of energy, as mentioned just now already. Okay, so the source of the energy is from the loss of the mass of the nuclear reaction. So the sum of the masses of the particles before the reaction is more than the sum of the masses of the particle after the reaction. So we are using this formula, mass defect. So that means the loss of the mass after the nuclear reaction here. Okay, so we're using sum of the masses before the reaction, which is with symbol Mi, minus the sum of the masses after the reaction, Mn. So this will be the very important formula to let you calculate, okay, for the problem solving later on. Okay. Okay, so loss of the mass in the nuclear reaction means that the mass has been changed to energy. So the energy is come from the loss of the mass, and the mass is known as the mass defect here. Okay. So according to Albert Einstein, the relationship between the mass and the energy is given by the equation E equal to mc squared. Just now I already mentioned 2 times. Okay, so what is the E? So E will be the nuclear energy released by the nuclear reaction, just now we mentioned. Okay, and after the nuclear reaction, so there is a loss of the mass, or we know as a mass defect. And C is the speed of the light with the value of 3 times 10 power 8. Okay, so the formula E equal to mc squared is another formula you have to memorize lah. Okay, but actually it's stated in the formula list already. Okay, so another one will be nuclear energy can be stated in the unit of electron volt. So there is another unit okay, for the energy, which is EV. Okay, 1 EV is equal to 1.6 times 10 power negative 19 joule. So this already teach at the previous chapter lah. Okay. Okay, so the 7, due to the masses of atom and subatomic particles being so small, a convenient unit to be used is atomic mass unit. Okay, so what is the atomic mass unit? The short form will be AMU. So for the BM will be unit gisim atom UJA. Okay. Okay. So the next will be the mass of the one carbon 12. 12 come together with 6 proton and 6 neutron. Okay, was chosen by scientists as a standard value. Okay, so the mass of the one carbon 12 atom is 12 AMU. So that means that the 1 AMU will be equal to 1 over 12 AMU from the mass of one carbon 12 atom. So I think this one, the student will be quite familiar also, because this is actually the chapter 3. Okay, chapter 3 for the chemistry from 4. Okay, so initially, okay, so they're using the hydrogen as the standard for the comparison now. Okay, and then because the handling problem for the hydrogen, they changed to using the carbon. So the carbon is 12 times heavier than the hydrogen now. Okay, so that's why they're using 1 over 12 here lah. Okay, for those actually is forget already. So this is the recall knowledge from the chemistry chapter 3 from 4 here. Okay, so actually the one hydrogen is equal to 1 proton, the mass for 1 proton lah. Okay, so that's why the proton and neutron actually they have the same relative mass. Okay, so that means that 12 proton and 6 proton and 6 neutron will be equal to 12. 12 times numbers of the hydrogen or proton here. Okay, so one more of the carbon will be 12 gram. Okay, and then the numbers of one more will be equal to 6.002 times 10 power 23 atom lah. Okay. Okay, so one carbon will be have these numbers, 12 divided by this. Okay, so will be have 1.99 times 10 power negative 23 gram. Okay, so 1 AMU will be 1 over 12 lah. Okay, so here will be 1.66 times 10 power 24 gram. So you have to know that how to apply. Okay, so 1 AMU equal to 1.66 times 10 power 20 negative 27 kg here in your calculation later on. Okay, so here is what I mentioned just now. Okay, so in SI unit, 1 AMU is the mass of 1 proton and also 1 neutron. So will be approximately 1 AMU. Okay, and then the mass of the electron is very, very small compared to proton and neutron. Okay, so here will be 0.0005 MU. Okay, so here actually is the continuous learning standard for 6.2.2. So here the 6.2.3 will be application of the formula E equal to mc squared, okay, in the problem solving, which is involving the radioactive decay and nuclear reaction here. Okay, so here I already show the solution. Okay, so the equation below represent a radioactive alpha decay, which occur simultaneously. So the question asks you to determine the mass defect in kg. Okay, so the mass defect, just now I mentioned already, the formula we're using here will be Mi minus Mf. So the Mi referring to the mass before the reaction. So will be, according to the formula here, so the reactants here will be the Ra, radium 22688. Okay, and then the unit, atomic mass unit already given as 226.035. And then the product will be 2 here, Rn and He here. So it will be 222.018 together with 4.003. Okay, Mf. So we just substitute to the formula. So the Mi equal to 226.025, and then the Mf will be 222.018 plus 4.003. So minus, we get 0.004 U. So 1 U equal to 1.66 times 10 power negative 27, which is given by the question also here. Okay, so we get the value 6.64 times 10 power negative 30 kg. Okay, so here 2 marks. The first mark will be given for the substitution. The second mark will be given for the answer with minimum 2 decimal places and together with correct unit here. Okay, and the next will be calculate the energy release from radioactive decay. Okay, so we'll be using the formula lah, E equal to mc squared. So the M we get from the 1, answer 1 here. And then the C will be the speed of the light, which is equal to 3 times 10 power 8 squared. So we get our answer 5.976 times 10 power negative 30. Okay, so again, will be also minimum 2 decimal places and with correct unit here. Okay. Okay, so we come to another problem solving, which is also related to the application of formula E equal to mc squared here. Okay, so this will be the another reaction. Just now for the problem solving one is the reaction regarding the radioactive decay. Okay, here will be the nuclear reaction. And from here, you can know that the reactants here will be have the smaller value of the neutron number, so will be lighter. Okay, and here will be bigger now we expected. Okay, as we know the knowledge from the nuclear fusion already. Okay, so here will be the nuclear fusion process. Okay, so based on the equation, X is the neutron of the helium. So determine the value of X. Okay, so this one actually is the question regarding the subtopic 6.1. Okay, so we know that the before reaction, the neutron number will be same as the after the reaction. Okay, so here we'll get 2 plus 2 here equal to X plus 1. So we get the value for X will be 3. Okay. And then the next will be the state the type of the nuclear reaction. Just now I already mentioned lah. Okay, so this will be the combination of the 2 lighter nuclei to form heavier nucleus here. Okay, so will be nuclear fusion. Okay. Okay, so the next will be the reaction. The nuclear reaction releases a large amount of energy due to the mass effect. Okay, so again, so this question asks you to calculate what is the value for the mass effect. So the table given the mass of the each nuclei stated in the atomic mass unit U lah. Okay, so we have to know the reaction first before the calculation. So for the initial will be here. Here will be Mi. Here will be Mf lah. Okay, so according to the formula, the Mi will be using 2 times this value lah, will be equal to value for these 2 adding together. So then we have to minus lah by using the formula, same formula here. Okay, and we substitute the value as mentioned. We have the 2 isotope of the hydrogen here. The value will be here 2.01410 times 2. Okay, here we have the 2 reactants lah. And then the final product will be helium this value together with the 1 neutron. So be here. So we minus, we get 0.0035 U here. Okay, so you can stop your answer here because the question not ask you to change any value, any unit to kg. Okay, so the 2 marks here will be first substitution, second will be the answer together with unit. Okay, the second one will be the calculate the energy release. Okay, so energy, so that means we're using the formula E equal to mc squared. Okay, for the M, we're using the value from here, 0.0335, and U will be equal to 1.66 times 10 power negative 27. Okay, and then the C will be here. So again, we substitute all the value to the equation. The first mark will be here. Okay, and then the second mark will be all together. So the third mark will be answer with correct unit. Decimal places must be minimum 2 lah. Okay. Okay, then we go to our learning standard 4. Okay, so the learning standard 4 will be describe generation of the electrical energy in nuclear reaction here. Okay, so you can look at the GIF here. Okay, so this is a nuclear reactor. Okay, and then the nuclear reactor will be generate electric, right? Okay, so this will be the application of the nuclear energy in generating electricity. Okay, so here, generation of electrical energy in nuclear reactor. So you can look at the figure here is quite complicated, okay? So if I say referring to the GIF, you actually can be classified the reaction to 3 circuit here, okay? The primary circuit will be referring to here. Okay, and then the secondary circuit will be referring to heat exchanger here. Okay, and then the tertiary circuit will be here. Okay. Okay, so let us discuss the importance component in the nuclear reactor here and its function. So the first one, nuclear reactor, so will be here now, is produce tremendous amount of energy through nuclear fission. So the purpose for the reactor is to produce the energy through the nuclear fission. Okay. So the nuclear fission, the fuel will be using uranium, the heavy elements lah. Okay, so the uranium will be the fuel. So be at here, the gray color area here. Okay, will be here, here and here. Okay, so the nuclei are splitting by neutron in a control chain reaction. Okay, so releasing a large amount of energy. The energy released heat out the cold gas that passes through the reactor core. Okay, so you can look at the figure. So here we have the cold water here, right? Okay, when it comes to here, will be heated by the uranium root. Okay, so the uranium root will be released the heat through the nuclear fission process. Okay, so the cold water will be changed to steam and go up at this way. Okay, so here is mentioned as the primary root. So be here. Okay. Okay, and then the next third component, here we have the graphic moderator. So act as a moderator to slow down the fast neutron produced by the fission, as we explained already just now for the nuclear fission process. Okay, so the neutron must be moving in slow motion, okay, so that will be able to capture by the uranium. Okay, so if I say there is a fast neutron moving in the reactor, so they will be facing the difficulties to have the nuclear fission process. Okay, so the graphic will be using to slow down the speed of the neutron. Okay, so that they will be more readily to capture by the uranium nuclide here. Okay, so will be at the black color. Okay, so will be here. Okay. Okay, now. Okay, so fourth, boron or cadmium control root. So the control root can be using two material, either using boron or cadmium. Okay, will be here. Okay, so the boron control root is absorb neutron. It can control the rate of fission reaction. So that means that to increase the rate of reaction, okay, or slow down the rate of reaction is controlled by the boron control root here. Okay, so when the root are lower into the reactor core to absorb some of the neutron, the rate of the fission reaction is reduced. As we mentioned already, the nuclear reactor will be conducting, okay, or producing the heat by fusion reaction, which is under the control. Okay, so which is in control, not under control, which is in control. So it's controlled by the control root. Okay, so you can look at the figure. So the control root will be this. Okay, if let's say they want to reduce the rate of the reaction, okay, so there will be more root will be come in now. Okay, so if I say they want to increase the speed, so the root will be pulled up lah. Okay, and then the fifth will be the heat exchanger. Okay, so the heat exchanger will be considered as a secondary root here already. So you can look at the green color GIF here. Okay, so the mainly is actually to cooling down the steam here. Okay, so the heat exchanger, heat energy from very hot gas is used to boil the water into the steam. Okay, so you can look at here. So just now, firstly, the heat produced by the nuclear reactor is to heat up the cold water, which will be changed to steam at the primary root here. And then the hot steam will be go here. So the water come from here. Here we have another cold water will be changed to steam. Okay, so the steam will be rotate the turbine here. Okay, so that means here, firstly, we change the nuclear energy to heat energy. And then from here, when the turbine is rotate, so the heat energy already changed to the kinetic energy here. Okay, and then further, you can see we have the table here. Actually, here here we have a generator now. So the generator is knowledge which actually you learn at the electromagnetism chapter already. Okay, so how the induced current is produced. Okay, is between the coin and the magnet. Okay, the relative motion causes the EMF or the induced current to produce lah. Okay. Okay, and then the sixth is a concrete seal. So concrete seal will be here. So prevent leakage of the radiation from the reactor core. Okay, so from PD3 or section 6.1, you know already. So for the radio decaying process, or now we mentioned the nuclear reaction, there is a radioactive ray will be emitted, okay, which is a gamma ray. Okay, so the gamma ray will have a very high penetrating power, so that they will be only able to stop by the concrete or lead. Okay, so the purpose for the concrete here will be used to prevent, okay, the radiation to come out from the radiator, from the reactor here. So the 7, here we have the cooling tower, but here is mentioned coolant. So the coolant actually, we have many parts. Okay, we need have the coolant here lah. Okay, so the coolant is an agent to cool down the steam, okay, or others lah. Okay, so take away the heat from the nuclear reactor. Okay, substance with the high specific heat capacity, such as water or carbon dioxide, are used. Okay, so the coolant is used to cool down the reactor. Okay, so because if I say the reactor is too hot, it will be able to exploding. Okay, will be very dangerous lah. Okay, for example, there is a nuclear disaster, okay, occur at 2011 at Fukushima, Japan. Okay, so it's due to the earthquake. Okay, causing the operating for the reactor become abnormal, under control. Is uncontrolled. Sorry, is uncontrolled, and causing the heat at the reactor become too high due to there is no coolant agent able to flow in to the reactor. Okay, end up the reactors explode. Okay, and causing a radioactive, okay, ray emitted in a wider area. Okay, so they will be dangerous if, let's say, the reactor is unable to cool down, okay, in certain period. Okay. Okay, so Cikgu Hasita, we can take a break.
Okey, baiklah pelajar, kita berhenti rehat seketika, kembali lagi selepas ini.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okey pelajar, kembali lagi bersama kami di Pusat Tuisyen Akademi Percuma AYU, bermula percuma selamanya percuma. Okey, sebelum cikgu serahkan semula kepada Mr. P, cikgu ingin kongsikan dahulu dua kod yang seterusnya, iaitu 84. Okey, sekali lagi dua kod yang seterusnya 84. Okey, pelajar-pelajar yang baru saja mengikuti kelas ini, tadi Mr. P telah bincangkan 4 standard pembelajaran. So mari kita lihat apakah standard pembelajaran yang terakhir untuk tajuk ini 6.2. Silakan Mr. P.
Okay, so thank you Cikgu Hasita. Okay, so saya boleh nampak chatroom ada satu kawan baik. Okay, Puan Tiu. Okay, thank you join my class. Okay, so kita sudah pergi ke standard learning terakhir, okay? So which is the justified the use of the nuclear energy as an alternative energy to generate electrical energy. Just now at learning standard 4, we know already how the nuclear reactor able to change the nuclear energy, okay, to heat energy, and then the heat energy will be converting to kinetic energy at turbine. And then the generator, which is connecting to the turbine, will be changed the kinetic energy to electric energy, okay, by electromagnetic induction. Okay, so here you can see there is a quite all already know that, okay, there is a war between the Russia and Ukraine. Okay, so here will cause a lot of the people dead, and then there is a loss of the construction. Okay, and the most important part here is actually causing another crisis here. So it's a energy crisis occur at the Europe. Okay, why? Because the EU country, normally they will be strongly dependent on the natural gas, which is imported from the Russia. Okay, so and what's the problem here? So causing the energy price will be up, and there is some of the demonstration at the Euro country there. Okay, so this issue already let the EU country, okay, think that is it they need to have the restarting, okay, for the nuclear electricity generating plant, okay, will be built at their country. Okay, so what is the advantage and the disadvantage, okay, for the nuclear energy? Okay, so here we can be comparison between three different generator power lah. Okay, so first will be coal, second will be the hydropower, and then the last will be the nuclear energy. Okay, okay, so for the first comparison between the cost construction, okay, you can see for the coal power generator will be cheaper lah, compared to the hydropower and the nuclear power station here. Okay. The second, if comparison for the cost of operating and maintenance, the nuclear power plant is actually showing there is a low operating cost. Okay, and the third is a comparison between the power plant location. Okay, so for the coal, they will be normally built at the circulated area, okay, which is far from the human settlement to avoid the air pollution, which will be affecting the health of the citizen. Okay, so that means that the coal power plant will be have the issue regarding the air pollution. Okay, then for the hydropower, okay, so will be near to the river dam because it needs heavy water and fixed consistent water volume. So we build near to the river or dam, okay, which can actually have a higher area lah. Need to have the potential energy change to the kinetic energy. Then for the nuclear power plant will be normally built near the sea or at shore, okay, because it require a large amount of the water supply, okay, to cool down the plant. Then for the fourth comparison between the effect to the ecosystem and carbon footprint. So that means this will be regarding the pollution. Okay, so for the coal power plant will be release large amount of the carbon, okay, which will be causing the air pollution, and there is an issue which is the global warming lah, okay, due to increasing percentage of the carbon dioxide in the air. Okay, and for the hydropower, deforestation and destruction of the ecosystem. So to build up the hydropower plant, so there will be deforestation occur. So this will be the negative impact if we choose for the hydropower plant, which is actually in Malaysia we have a lot of the hydropower plant. Okay, but another way is it is actually clean and no carbon footprint issue here. Okay, because no carbon will be released for the hydropower plant here. Then for the nuclear power plant, here will be also clean, no effect to the ecosystem and carbon footprint. So that means that the nuclear power plant is considered is environment friendly alternative energy, which actually we can think to use lah, okay, in future. Okay. Okay, so the next will be the issue and health, safety and health issue. Okay, so definitely just now we know already for the coal power plant, okay, they will be release a lot of carbon and causing the air pollution and the global warming issue also lah. Okay, so where now many of the big country want to reduce their carbon release by changing their energy to more clean. Example, solar, example, hydropower plant, and also nuclear energy. Okay, so for the hydropower, so they will be can control flood. So I think Malaysia, we need to think more hydropower plant, okay, because we have a lot of the problem at the Terengganu, Kelantan, this area, right? So they will be faced flooding, especially during end of the year, okay? So no health issue. So that means that hydropower plant is actually also quite good lah, quite environment friendly. Okay, then for the nuclear, highly secure storage system, high risk of leakage. Okay, so this is the problem where actually just now I mentioned already, example, the Fukushima nuclear disaster, which occurred at 2011. Okay. Okay, so that means here the hydropower plant showing that there is more safe and less health issue lah. And then for the technology and expertise, okay, so for the coal power plant, low safety issue, but causes a high health issue. So safety issue, no, but the main problem is pollution. Okay. While for the hydropower plant, require high technology and expertise in electrical field. So that means for building the hydropower plant, we need to have the high technology and high science knowledge actually. Okay. For the nuclear power plant is also the same. Require high technology and expertise in the nuclear field. Expertise from other engineering field. Okay, so that means for nuclear power plant, we need to have a very high technology so that we can reduce the risk of the leakage. Okay. Okay, then the last one comparison is regarding the waste management issue. So for the coal waste products such as mercury require expensive control system of air and water pollution. Okay, so definitely I think the coal will be long term is not a best choice okay. Then for the hydropower plant, no waste to be managed. For the nuclear, require high expertise to manage the waste product. So for the waste management issue, definitely the hydropower plant will be the best okay. However, there is a limitation for the hydropower plant. So that means they need to have the river, right? Okay. So nuclear power plant will be another alternative okay, so that we can have our variety in the energy application. Okay, so not so depending on one of the source of the energy, for example, the gas and the petroleum, which will be also going to finish very soon. Okay. Okay, so we have actually finished our subtopic. Okay, and we have 3 questions here, 2 questions section A, and 1 question in section B here. Okay, so for the first question, diagram show nuclear fusion of uranium-235. Give one reason why uranium-236 splits into 2 new elements after the reaction occur. Okay, just now we mentioned already, the uranium-235 will be bombarded by 1 neutron, so that the 236 uranium will be unstable, so it will be splitting very quickly. So the answer here will be uranium-236, which is very unstable and splits quickly when bombarded by neutron. Okay, so this will be the answer Okay. Okay, then the next, using only the information given in table 3 and 4. So be here. Okay, compare the nuclear fission and nuclear fusion. Hence, that the relationship between the mass and energy involved. Okay, so here you can look at the figure. Table 3 will be here. So this will be the nuclear fission. Okay, and then for the table 4, there will be nuclear fusion here. Okay, so first compare the nuclear fission and nuclear fusion. Okay, so here you can see from the table. So you can see the reactants, okay, before the reaction, so will be higher neutron number. Then the product will be has a lower neutron number. Okay, so that means the first point here will be nuclear fission is splitting of heavy nucleus if using the information given in table 3 and 4. And then the second, the fusion, you can see there will be lighter reactants compared to the product. So here will be nuclear fusion is the combining the several light nucleus. So here will be isotope hydrogen, okay, to become a heavier nucleus. Here will be the second mark. Okay, then the third mark will be the mass. So you can look at both of the table 3 and table 4 here. Both showing the loss of the mass. Okay, so from the table 3 to 240 become 239. Then for the table 4, you can see from 5.03 drop to 5.01. So both showing the loss in the mass. So will be the third point here. So we have total 5 marks have to score here. So that means we need to have minimum 5 points here. Okay, so the next here, the energy. Okay, so you can look at both also produce the energy. Okay, so the fourth mark here will be energy is released for both processes. Okay, so the fifth mark will be using the formula from the formula list. You can see the energy released for both will be using same formula. Okay, E equal to mc squared. So this is a relationship between the mass defect and the energy produced. So the fifth mark will be the formula which relate the mass defect and the energy release. Okay. Okay, then C will be the calculation. Based on the above equation, calculate the energy release in the nuclear fission process. The mass defect during the process is 0.18606 U. Okay, so again, we're using the same formula, okay, because the question asks us to find the energy. So E equal to mc squared. So the M will be 0.18606. So we have to times this value, 1.66 times 10 power negative 27, change to kg. Okay, and then C square. So will be like this. Okay, here will be square. Okay, here will be square. Okay, here will be square. And then you get this value. Okay, 2.78 times 10 power 11 joule. Okay, so the question 2, okay, will be colon SPN question, section A. Question modification. Okay. Okay, so diagram show a structure of nuclear power plant. The plant produce nuclear energy through nuclear fission reaction. Okay, so what is the nuclear fission? So this is the first mark, understanding. Okay, So just now we already know lah. You have to give splitting heavy nucleus into two lighter nuclei come together with the large amount of energy. So these 3 points you have to mention lah. Okay. Then calculate the nuclear energy produced from the nuclear fission reaction if the mass effect will be this 2 marks. Okay, so this question will be similar with the question 1 lah. Okay. So for calculate the energy, we're using E equal to mc square lah. And then the M already given in kg. So we straight away substitute M with this value. No need to times anything already. Okay. And then C will be this value square. So you get 2.78 times 10 power negative 11 joule. First mark for substitution. Second mark for the answer with minimum 2 decimal places and correct unit. Okay. Then C will be the modification question here. Okay. So nuclear power plant in diagram, okay, in diagram is proposed to build in Malaysia. Okay, so give suggestion based on the following aspect so that the plant can be operated safely. Okay, so the first location of the nuclear power plant, just now we mentioned already, due to we need the water which acts as a coolant agent, okay, need to reduce the temperature of the nuclear reactor. So we have to build near the sea, river or lake, okay, to get the supply of water lah. Reason, easy access to water, cooling continuously. Okay, so this will be the preferred answer. Then the next will be the thickness of the wall of the containment building. So as mentioned, we need to have the concrete to prevent the emitting of the radioactive ray from the nuclear reactor. So that means thickness, we need to have thicker lah. Okay. So thicker, so that can prevent leakage of the radiation from the reactor core. So this will be the answer, which actually mentioned in the discussion just now already. Okay. Okay, so for the coolant material, okay, as per mentioned just now, we are using water or carbon dioxide. Okay, so because both have the high specific capacity, especially the water lah, cheap some more. Okay, so can absorb more heat. So this is a reference answer for this question. Okay, then we go to our last question here, 20 marks question. So this will be the column SPM question for section B. So that means this will be the decision-making question here. Okay, so a nuclear reactor uses fission of uranium-235 for generation of electricity. Slow-moving neutrons are used to bombard uranium-235 nuclei. Explain why energy is released in the fission of uranium-235. Okay, so for this question, you can actually using the formula to explain. Here we have 2 marks. So what we have to write? So firstly, you can using this formula, mass defects equal to Mi equal to Mf. So that means the mass for the final reaction will be less than the mass at the beginning reaction. So this will be the first mark. Total mass after fission, F is less than the total mass before fission. So this will be the first mark. You can explain by using the formula. The second will be E equal to mc squared. So the energy released is equal to the energy equivalent to the mass effect here. Okay, 2 marks by using the formula can be explained. Okay, then the next 2 marks question, write the energy transformation in nuclear reactor. So just now we already also explained. in learning standard 4 already. Okay, so here you can see the first, the reactor versal here. So it will be the nuclear reactor. Okay, so the nuclear fission is take place in the reactor with the energy release E equal to mc squared. So here you can see the energy will be converted to heat energy here. Okay, and then the heat energy will be converting to kinetic energy. Okay, because the heat produced from the reactor will be heat up here, the secondary loop here, right? Just now we mentioned already. The blue color one here. So the steam generator here. So the steam generate will be rotate the turbine here. So that means change to kinetic energy already. And then here you can see at the generator. So this will be the recall section for the section 4.2, okay, electromagnetic induction. So inside the generator, there is a coil together with the magnet. Okay, so the process of the production induce EMF or current with the relative motion between conductor and magnet. So that means the turbine causing the relative motion, okay, occur between the conductor and the magnet, which is inside the generator, so that the electricity will be produced. Okay, so here, the answer here will be nuclear energy will be converted to heat energy and then to kinetic energy, and last will be electrical energy here. Okay, so step one, advantage of using nuclear, okay, of nuclear energy for electricity generation. So just now for the learning standard 5, we can see a lot of the advantage from the nuclear power plant here. So here 1 mark, 1 point. So here answer for reference will be no emission of the pollutants such as the smoke or carbon. Okay, so will be 1 mark. Okay, then next question. A nuclear reaction is represented by the following equation. Okay, so the equation will be like this. Okay, uranium bombarded by neutron produce 2 lighter nuclei here together with 2 neutrons, release the energy here. Okay, so the mass for the each component, each element here stated here already. And then the 1 AMU is given also, the speed of light also given already. So the question, 5 mark for section B for the calculation. The first question here is to calculate the mass defects in kg. Okay, so again, using this formula, M equal to Mi minus Mf. Okay, so the Mi will be here. Mass of 1 neutron plus mass of the uranium. So with this plus this equal to this lah. Here will be here. This value will be here. So CS will be 140.91963 will be this. RB will be this 92.92157. Neutron we have 2. So will be this value times 2. Okay, so minus we get 0.19405 U. Okay, so the question asks us to convert in kg. So 1 mu equal to this value. So we multiply, we get answer 3.22123 times 10 power 28 kg. Okay, so here definitely is more than 2 decimal places already. Okay, so you can see all given value is more than 2 lah. Actually is you can maintain 5 decimal places here lah. Okay, then the next question will be energy release. So energy release will be using same formula, E equal to mc squared. So we substitute M where the answer in 1. Then the C is given here, square. So you get your answer will be this, 2.899107 times 10 power 11 joule. Okay, then last will be the 10 marks decision making question here. Okay, so diagram show a nuclear reactor which is used to generate nuclear energy. Okay, so you are required to investigate the characteristic of the picture in the nuclear reactor in table. So the table will be here. Okay, so explain the suitability of each characteristic of the picture in the nuclear reactor, which can generate a controlled nuclear reaction safely. Okay, so determine the most suitable reactor to use. Give your reason for your choice. Okay, so here, there is a 4 option for you, okay, PQRS. Okay, so firstly, you have to choose the correct material for moderator. Okay, so advise the answer in table as usual. Okay, so the moderator will be here. Okay, moderator will be here. So what is the material you can choose? So here we have 2 options. You want to using the graphic or using the iron. So according to our notes just now, we will choose graphic. Okay, we'll choose graphic. So will be P and R. So Q and S will be out already. So reason, just now we mentioned, we want to slow down the velocity of the neutron so that the uranium will be more readily to bombard by the neutron. Okay. Then the next will be the control route. So control route will be here. Okay, so is to control the numbers of neutron. We want to control the rate. So here 2 options, krypton or boron. Definitely this one you have to memorize. Will be boron. Okay, or cadmium. If I say we're referring to the explanation just now. Okay, so here no cadmium is boron. So definitely we'll choose boron. Okay, to absorb the neutron to control the chain reaction rate actually. Okay, then the next will be the coolant liquid here. It will be here. It will be here. So we have 2 options also, water and oil. So definitely we choose water. Okay. So why? Because the water have a high specific heat capacity, or can absorb heat easily also can. Okay, then the last will be the thickness of the concrete seal. Will be here. Okay, so we'll choose the thick one to prevent leakage of the radiation from the reactor core. So we are clear that we'll choose R. We'll choose R. Okay, then we copy all. So the graphic used as moderator, the first one. Okay, and then boron used as the control route will be here. Then cooling agent we're using will be water, and thick concrete wall will be choose. Okay, that's all for my sharing today. Thank you.
Thank you very much Mr. Pei. Terima kasih di atas perkongsian sebentar tadi. So it's a very vivid and crystal clear explanation. So students, from what I can conclude for this chapter, so altogether we have 5 learning standards. The first one is the two process involving fission, involving production of nuclear energy, which is nuclear fission and fusion. So make sure you know what is the differences between these two process. Pastikan anda tahulah apa beza fission, pelakuran dan pepelahan nukleus. And second, we've come with the equation we apply to calculate the amount of energy produced from these two process, where E equal to mc squared, a very famous equation proposed by Albert Einstein. And then the third learning standard, how we apply this equation to solve a problem relating to generations of nuclear energy from fusion and fission. And then the fourth learning standard is the generations of electricity. Mr. Pear have discussed with you the reactor plant, what is the function for each part, apa kegunaan setiap bahagian, and last but not least is to justify the use of nuclear energy as an alternative energy sources. So he has given you 3 comparison between the 3 sources, coal, hydro, and nuclear as well. So what is the advantages and disadvantages for all also have been given. So I hope this session benefits for those who join us from the beginning until this minute. Okay, terima kasih Mr. P, dan tahniah juga kepada semua pelajar yang tekun mengikuti kelas kita pada petang ini. Diharap perkongsian yang kami berikan ini memberi manfaat kepada anda, khususnya yang bakal menduduki peperiksaan percubaan. Sekarang ada certain tempat sudah bermula dan ada juga yang akan bermula pada minggu hadapan. So kami doakan anda semua lulus dengan cemerlang dalam bukan saja fizik tapi semualah subjek yang anda ambil di sekolah. Okey, jadi link telah dikongsikan oleh Cikgu Kok dan Cikgu berikan dahulu 2 kod yang terakhir, iaitu kod kita 98. Okey, 2 kod yang terakhir 98. Okey, sebelum kita tamatkan sesi pada petang ini, Cikgu nak jemputlah sahabat Cikgu untuk memberikan sedikit ucapan ataupun kata-kata semangat untuk pelajar kita. Silakan Cikgu Kok.
Okey, untuk belajar-belajar, sekarang masa memang sempitlah kerana ada sekolah untuk ras silibus dah habis. Sekarang kemudian percubaan pun coming soon lah. Ada sekolah sudah on, ada sekolah coming soon. So harap belajar yang AYU ni memang sangat menolongkan anda semualah. Kerana semua topik form 4, form 5 semua pun ada. Okay, so belajar-belajar anda boleh dapat percuma mendapat ilmu daripada AYU Akademik ni. So belajar sila jangan buang masa lagi dan juga menumpu perhatian kepada apa-apa yang cikgu share kat Akademik YouTube. Okay, selamat mengambil peperiksaan percubaan dan juga SPM. Terima kasih.
Okey, terima kasih Cikgu Ko. Okey, Mr. P, silakan sedikit kata-kata terakhir untuk petang ini.
Okay, so good luck kepada semua pelajar yang nak menghadapi periksa. Okay, so sebenarnya kita pun tinggal lagi last chapter saya rasa. So kita pun soon lah nak habiskan syllabus. Okay, so teruskan bersama AYU. Okay, so terima kasih.
Okey, terima kasih Mr. P. Okey, jadi jangan lupa teruskan bersama kami minggu hadapan. Kita ada 1 kelas saja untuk tingkatan 4 kerana minggu hadapan untuk slot tingkatan 5 kita tak dapat bersiaran. Tapi kita akan sambung pada 20 November nanti untuk topik yang terakhir iaitu bab 7. Quantum Physics. Okey, itu adalah satu tajuk yang barulah untuk silibus tingkatan 5. Okey, minggu depan bersama dengan Cikgu Rina untuk subjek tingkatan 4. Tajuk dia adalah pantulan gelombang. Okey, jadi teruskan bersama dengan kami di Akademi YouTuber dan rajin-rajin mengulang kaji. Yang penting jaga diri, jaga kesihatan di musim-musim hujan ini. Jadi pastikan anda dalam keadaan yang terbaiklah untuk menghadapi peperiksaan percubaan. Jadi sekian dulu daripada kami. Mohon ampun dan maaf di atas segala kekurangan dan kesilapan. Sesungguhnya segala yang baik daripada Allah Subhanahu Wa Taala, yang lemah itu daripada kekurangan diri kami. Jumpa lagi dalam siri yang akan datang. Terima kasih dan bye-bye semua.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.